In this lesson, we're going to go through many examples of permutations and combinations. So let me remind you of what a permutation is. I always say it's an arrangement where order matters. So a permutation is written in the form of capital P, and then there's this lowercase subscript n and r. I state from n items, we're choosing r items. In combinations, we're selecting groups of objects. The notation for combination is very similar. It's from n, choose r, but there's a capital C in the middle. A permutation, let's understand it with an example. So if I had a permutation from 6, choose 3, so I have 6 things to choose from and I'm ordering them into 3 positions. So I always put 3 little marks, and I have 6 choices for the first. Now one thing is there, 5 choices for the second, and 4 choices for the third, and the fundamental counting principle says multiply it together, and I would get 120 different arrangements. Now a combination is equal to a permutation of the same thing, but then we have to divide out our repeats. So it's a permutation from n, choose r, but we divide by r factorial. So this would be equal to a combination from 6, choose 3, is equal to a permutation of the same thing, which we know is 6 times 5 times 4, we just did it, divided by 3 factorial, which is 3 times 2 times 1 to eliminate the repeats. So now I'm going to have 120 divided by 6 is going to be 20 combinations. So let's go through a ton of scenarios to shed more light on this issue. So we are just going to decide if this is a permutation or a combination. So a team of 8 basketball players need to choose a captain and a co-captain. To me, this is a permutation because if you have a captain versus a co-captain and you switch who's captain and co-captain, that order is definitely going to matter here. So this is from 8, I'm selecting 2 people to fill those positions. Rob and Mary are planning trips to 9 countries this year. There are 13 countries they would like to visit. They are deciding which countries to skip. So this would be a combination because the order in which I'm visiting the countries doesn't really matter. Like I could go to Italy and then France, that's still the same as then France and Italy. So it's just which can I make a group of, which 9. The batting order for 7 players on a 12-person team. So definitely order matters here. This is an example of a permutation. There are 45 applicants for 3 computer programmer positions. So this is also a combination because I'm selecting 3 to be a group. It's not like position 1, position 2, position 3. Using proper notation, this would be from 45, I'm selecting 3. Now we're going to actually compute the number of outcomes. So Castel and Joe are planning trips to 3 countries this year. There are 7 countries they would like to visit. One trip is a week long, another 2 days, and the other is 2 weeks. So to me, this is a permutation because of this portion of the sentence here. They're staying at these countries for different amounts of time. So this would be a permutation from 7, choose 3, and we're going to actually calculate this. So I have 3 places I'm choosing to go. So it means I have 7 choices for the first. Now I go to one place like Italy, so now I have 6 places. Maybe I go to France, so now I have 5 choices remaining. I multiply this together, and I get 210 arrangements. All right, 6. There are 110 people at a meeting. They each shake hands with everyone else. How many handshakes were there? Well, this would be making groups of 2. So if person A shakes hands with person B, that's the same as B shaking hands with A. So order here doesn't really matter. So it'd be 110. I'm just doing groups of 2 as they shake hands. So this is equal to a permutation of the same size. So in the numerator, I would have 110 times 109 divided by the second number factorial would be 2 times 1. This is equal to 5,995 handshakes. You are setting the combination on a 3-digit lock. You want to use the numbers 1, 2, and 3, but don't care what order they are in. Don't be fooled by this word combination. This is actually a permutation because order matters when you're opening a 3-digit lock. 3, 2, 1, 1, 2, 3, these are different arrangements. So how many different arrangements do we have? Well, we have 3 numbers to choose from, and we're choosing all 3. So 3 choices for the first, 2 for the second, 1 for the third. So there's 6 different possible lock. Now I'm going to use the word combinations, even though that's technically a permutation. A group of 25 people are going to run a race. The top 8 finishers advance to the finals. Now this tells me all 8, a group of 8, go on. So that makes it actually a combination, and often when we talk about how many different ways can somebody cross the finish line, that's a permutation, but since all 8 move on, it's a combination. So this is equal to a permutation of the same size. So I put 8 little blanks here, and I'm going to count down 25, 24, 23, down to 18, divided by the second number factorial, 8 times 7, 6, 5, 4, 3, 2, and 1. So how many different groups of 8 could I create? This turns out to be 1,081,000. That's an 8. 575 groups. And that's sloppy. Let me fix that 8. A team of 17 softball players need to choose 3 players to refill the cooler. So I just need a group of 3. This is a combination from 17, choose 3. See if you can get the answer. Hit play when you're ready. So this is equal to combination or permutation of the same size, 17, 16, 15 choices for each of the 3 players, divided by the second number factorial. This produces 680 different groups of 3. Okay, for the next, there's 4 more problems. I want to see if you can read through each scenario and figure it out. All right, pause the video, hit play when you're ready to see the solution. This is a combination from 13, choose 5, and I get 1,287. You read through this scenario, pause the video, hit play when you're ready to see the answer. It's a permutation from 10, choose 4, 5,040 ways they could fill the offices. Again, pause, read the scenario, hit play when you're ready to see the answer. Here it comes. So this one's actually a combination, and it throws kids off because they think batting order, well, order matters, but this says selecting which 7 players will be in the batting order. So it's just which group will make it up, which makes it actually a combination of 330 groups. Okay, 15 applicants for 4 jobs. How many ways could they fill it? Pause, hit play when you're ready to see the solution. It's a permutation from 15, choose 4, and there are 32,760 ways they could fill those positions. Here's your last one. See if you get this one perfect. This is a permutation from 45. You're selecting 3 to earn these medals. So there's 85,140 ways they could earn these medals.